In this problem, we were asked to find the remaining zeros if we know that 3 minus 4i is a 0 for this polynomial. Well, to do that, we need to remember, if I told you that x equals 5 was a 0, I just made that up, I'm not saying that it is. But what if x equals 5 is a 0? That means that x minus 5 is going to be a factor of that, right? So we would just use the 5 in synthetic division and see if it gives us 0. You do the same thing here. We know that 3 minus, that's supposed to be a 4, 3 minus 4i is a 0 of this polynomial. So our synthetic division is going to be a little bit crazy. Let me see if I'm missing 4, 3, 2, 1, 0. So 48, 12, and negative 50. So many times I write down the problem and just miss a negative and it throws everything off. So I want to double check that. Let me fix this real quick. There we go. Okay, so we still bring the first one down and multiply 2 times all of that. I'm going to actually come down here and write it down so you can see what I'm doing. 3 minus 4i, so 2 times that is 6 minus 8i. So I put 6 minus 8i here. Remember, you add the real parts, add the imaginary parts. So this is going to be negative 6 minus 8i. Now we multiply these two. So that gives us negative 18 minus 24i plus 24i and positive 32i squared. That's 0. That's negative 1. So we have plus 32 times negative 1, right? So negative 18 minus 32 is going to be a negative 50. So we put negative 50 here and add, that gives us a negative 2. Now we multiply these two. So we have negative 2 times 3 minus 4i, negative 6 plus 8i. So negative 6 plus 8i. That gives us 6 plus 8i. Now we multiply. It should be very similar to this one, right? I'm going to go ahead and multiply it anyway so you can see. 3 minus 4i times 6 plus 8i. That's 24 plus 20, that's not 24, that's 18. That's 24 minus 24i and then minus 32i squared. So we have 18 minus 32 times negative 1. So 18 plus 32 is 50. And when we add those, we get 0. So right now, we can see that we have, let me bring all of this down here. I use a different color. It's getting a little crazy on this paper. So P of x is equal to x minus 3 minus 4i, and that's that one right there, by the way. X minus that is here, and then we have here, we're going to reduce our original exponent, so we have 2x cubed. Then how do I want to write that? Do you see how this is both negative? So I could actually factor a negative out, right? So I'm going to do that. Minus 6 plus 8i x squared minus 2x and then plus 6 plus 8i. So let's review what I just did. 2x cubed, x cubed, all this x squared, that's x, and that's your constant. So it looks a little bit crazy at the moment. If we were, all they asked us to do was to find the zeros. So we don't actually have to continue writing this in factored form. We just need to find all the zeros. Well, inside here, it looks like we can factor this by grouping. Group together these two and group together these two. We can factor out, there's actually a couple of ways we can do this. I'm trying to think of the way that would be easiest for you to see it. In the first two, we could factor out an x squared. Let me just go ahead and do that since I already have it written that way. Keep in mind, if you wanted to, you could rearrange these. You could put this minus 2x over here so that you have your two x's together. Then you could put this term, all of this, the minus 6 plus 8i x squared, you could put this over here. So you could switch the two in the middle. I might show you that one as well if we have time at the end of the video. Okay, so if we factor it as it is, we're just working on this part right here. Nothing else, just this. So we factor out our x squared from here. That leaves us with 2x minus all that stuff, right? So minus 6 plus 8i. So that's this one. We factored out our x squared. Here, there's nothing in common. So what we're going to do is just factor out a 1. Actually, I'm going to factor out a negative 1. Negative 1 times 2x minus 6 plus 8i. I think I need one more. No, I think that's all. Now if you look inside these two pieces, all the stuff that's in parentheses is the same. So we factor out the 2x minus 6 plus 8i, and we're left with x squared minus 1. So now we can actually finish this problem. They asked for all of the zeros. So set each of these factors equal to 0. Sorry, I moved my camera. There we go. So we have 2x minus all this. And we have x squared minus 1 equals 0. If you move this entire thing to the other side, you get this. Divide both sides by 2, so x is equal to 3 plus 4i. This is another 0. If you move the 1 over, we have x squared equals 1. Square root both sides, don't forget plus or minus. So x is equal to 1 and negative 1. These are the other two zeros. So we have now found the other three zeros when we know that 3 minus 4i is one of the zeros. Now there's another way you could have worked this. If you know that 3 minus 4i is a 0, you also know that 3 plus 4i is a 0. You automatically know that. And look what we found. We did find that 3 plus 4i is one of the zeros. So you could actually create these two factors, x minus 3 minus 4i, x minus 3 plus 4i. It takes a little bit of work, but you can multiply all of this out and you find one of your real factors. It's pretty cool when you work it out that way. But I wanted to show you how you could factor this in a different order. So if you're not interested in that, by the way, go ahead and stop the video. So I've got to do a little switching back and forth. Here, let me do it this way. Alright, so we have 2x cubed minus 6 plus 8i x squared minus 2x plus 6 plus 8i. That was our polynomial that we needed to factor, and it does have some imaginary or complex coefficients. So what we want to do is rearrange it. So we have 2x cubed I'll bring this one over. So minus 2x, and then I'll put this one. Minus 6 plus 8i x squared, and then plus 6 plus 8i. Now you can see these have something in common, right? Here you can factor out a 2x, and you're left with x squared minus 1. Here you can factor out a negative first of all, but this whole parentheses. So minus 6 plus 8i, you're going to factor that out. You'll be left with an x squared, and you'll be left with a plus 1. Sorry, a minus 1, because we're factoring out a negative. Now you can see that we have an x squared minus 1 in each of these. So factor that out. And then you're left with the 2x minus the 6 plus 8i. You can factor that again, difference of squares. You can factor out a 2 from that one. We'll stick it out front. We'll have x minus, going to distribute that at the same time. So x minus 3 minus 4i. So there are lots of different ways you could approach this problem. This is just 2 of them. Maybe 2.5 of them. But what we were really asked to do was just find those other zeros, which we already did on the previous page.